Hello everyone, thanks for visiting the channel again. Today we have a very interesting topic which is about air pollutants and their spread over our atmosphere and how it actually have serious environmental and health concerns. So air pollution can be based through activities which happen in nature and as well as which is done by humans, the anthropogenic activities, man-made activities. So both of these type actually generates the air pollutants. We will more focus on the man-made activities which has uh, disturb the actually the balance of nature, because the air pollutant released by the natural activities are actually uh, act as a uh, balancing of some of the features which are important for life on earth. So we will more focus on man-made activities in this video. So, air pollutants generated through man-made activities can be categorized into primary pollutants and into the secondary pollutants. So, in primary pollutants, one of the major and significant area which is responsible for these air pollution is the combustion of hydrocarbons for energy. And similarly, the agriculture and livestock and other land use activities also generate air pollutions and releases pollutant into the air and atmosphere. Industries also releases a specific type of emissions depending upon the process and the manufacturing they undertake. In context of energy, where especially where we uh, combust the hydrocarbons, where carbon, hydrogen, nitrogen, sulfur, and oxygen are the main ingredient in these hydrocarbon fuels. So when we combust with the air, it releases the carbon dioxide, which is one of the biggest challenge, the carbon monoxide, and if we combust solid fuels especially, we also release particulate matter, which is one of the very serious health concern for humans. So those particulate matters are actually unburned carbon soot and other stuff which come with the solid hydrocarbons like coal and biomass. So these particulate matters can be further subdivided into two broader categories. One is the particulate matter 10 and one is PM 2.5. These denotes the size of these particulate matters in terms of the micron. So the most dangerous for health is the PM 2.5, as it cannot be uh, separated by our nose and directly reaches or interfere with our respiratory system, and these are actually deposited to lungs as well. So one of the main concern for these PM 2.5, as they are very small and tiny particles, so they need once they are airborne, they need almost a few weeks to settle down, and in the time of week, they can spread far beyond the source or their origin from. So a lot of more population and communities can be affected, which might have a distance of hundreds of kilometers from the source or origin of these combustion areas. So another very dangerous aspect is these particulate matter also have uh, lead and mercury contamination, which are part of some coal and some other hydrocarbon deposits. So these make these emissions more toxic and carcinogen. The water vapor also a byproduct for hydrocarbon combustion. Similarly, when we have a nitrogen in the fuel, The NO and NO2, which are known as the fuel NOx, will also be released into atmosphere. Since we take oxygen for combustion from the air, so it uh, generates two different types of NOxes along with fuel NOx. Uh, One is the thermal NOx. When the mixture reaches to a temperature beyond 1300 degrees Celsius, the nitrogen and oxygen react uh, and form NO and NO2, and at these high temperatures there are also chances to uh, react the reaction of nitrogen from air with the radicals from the fuel. So these reactions also generate NO and NO2, and normally known as the prompt NOx. So these are the three types of NOx. When we call it NOx, it primarily means NO and NO2. So when we have a sulfur in the fuel, or like hydrocarbons in coal, the SO2 will be released. Similarly, from the agriculture and livestock, where we use a lot of fertilizers, ammonia is released as an air pollutant. N2 is also released from livestock and agriculture. Methane due to decay of organic matter, which also a part of waste decay as well. So these also generate methane, very very uh, dangerous gas in terms of global warming potential. From waste, especially from the wastewater, the H2S gas, which is also a harmful air pollutant, is also generated. From the industrial emissions, where specific refrigeration equipment is present or in the inventory. So these are the chlorofluorocarbons and perfluorocarbons, which are released or leaked into the atmosphere, which has a serious consequence, especially for the ozone. Other gases may include the volatile organic compounds. Similarly, the SF6, which is part of most industrial electronic equipment, so that is also a very very high concern, especially in terms of global warming potential. So these can also be released from the industries. Uh, these pollutants, these primary pollutants, are not only harmful in its own, but they can generate new kind of pollutants which are more harmful and are known as secondary pollutants. Um, so one example is this ozone, especially in the troposphere, in the lower atmosphere, where we consider ozone as a air pollutant and bad thing. It is generated in the presence of sunlight when NOx reacts with the volatile organic compounds, and when this ozone actually further reacts with the particulate matter um, um, originated from some hydrocarbon combustion, and mixed with further with the water droplets with volatile organic compounds, aldehydes, and actually results this photochemical smog, which is a very very serious health concern, um, especially in the developing countries, where we have a high uh, concentration of photochemical smog, especially in the season of winter. So if we see these, as discussed in the start, that the nature also releases the air pollutants, and most of them are biogenic in nature. And these biogenic sources releases N2O, decay releases methane. N2O is of significance because N2O have a very uh, stable and long life in the atmosphere, and naturally it is formed due to the lightning of clouds, and it's actually uh, also one of the reason of depletion of ozone, which protect us from the harmful UV radiation from sun. Naturally, VOCs are also emitted. Volcanic eruption also and wildfire also uh, generate the carbon dioxide and the carbon monoxide, but all these were in actually balance to sustain the life on earth. But if you see the spectrum of this all man-made air pollutant, which has actually disturbed the balance over the years since the industrial age. So now we see how these actually are present in atmosphere, or what are the different layers of atmosphere on what we call the Earth atmosphere, the terrestrial atmosphere. This considers the Earth's surface. We have a lower atmosphere and we have an upper atmosphere, uh, broadly classifying this overall atmosphere of Earth. The first layer is the troposphere, which has an altitude up to 12 kilometers starting from the Earth's surface. The second is stratosphere with altitude up to 50 kilometer. The third one is the mesosphere, which has an altitude up to 80 kilometer. The fourth is the thermosphere, altitude as high as 700 kilometers. And the last one on the Earth atmosphere, it is the exosphere, and troposphere we call the lower atmosphere, and remaining other layers are called upper atmosphere in the Earth atmosphere. So each layer is um, actually have a barrier. The first barrier, we have a tropopause, which is also known as temperature inversion zone. Stratosphere actually ends with a stratopause. Mesosphere ends with the mesopause, and represent one of the coldest region in the Earth atmosphere. Thermosphere is uh, ended at the thermopause, and the exosphere actually ends, and afterwards interplanetary space starts. So when we see these in terms of the air pollutants, most of these activities, as discussed earlier, um, man-made pollutants are released into the troposphere. In troposphere, the altitude, as altitude increases, the temperature drops. In stratosphere, as altitude increases, temperature also increases. In mesosphere, when altitude increases, temperature again drops. And in thermosphere, when altitude increases, temperature also increases. And the molecules of oxygen and nitrogen present in this region are actually directly hit by the photons and high energy rays from the sun. So the temperature gets heated up in this region. So the pollutants, primary and secondary pollutants discussed earlier, are mostly found in this troposphere, and since we all directly interact with these, and so these directly results in serious health concerns. And these pollutants can stay uh, starting from an hours to weeks and remain into the atmosphere in this form after the release. Water vapors are also part of these, you can say, combustion products, and these water vapors are integral part of the water cycle, and most of our water cycle is also contained in this troposphere. Clouds form in this troposphere region. Surface water evaporation, evapotranspiration occur in this troposphere. So water cycle, these water vapors are integral part of the water cycle. So these remain always remain in the air. So even though they have a global warming potential, but these are considered very short-lived at a certain place because they changes phase and transform into one phase to another phase. So these are not directly considered as a greenhouse gas or global warming catalysts. So if we consider these pollutants in terms of their life in atmosphere, how long these pollutants will stay in the air, how much they can damage the ozone, and how much they can result the global warming. So these can be the three features of a dangerous air pollutant in the atmosphere. So first we take the carbon dioxide, which is the most released air pollutant, especially in context of global warming. Since its life is more than 100 years in the atmosphere, so that is so this actually for better understanding, this means that if carbon dioxide by combusting the fuel is released in 1925, it will still be present in 2025. So that's why it's an alarming, because the accumulation increases with every passing moment. The global warming potential is set as a 1 as a benchmark for comparing with other global warming greenhouse gases as well. Ozone depletion is not a challenge for CO2, but the real challenge is this global warming phenomena. Similarly, for methane, the ozone depletion is not an issue, but it is 28 to 36 times more potent global warming gas when compared with the carbon dioxide. The life still has in years. It requires 12 years to actually break down. So that is also a very because the global warming potential is at 28 times or 36 times. So it is also a significant contributor to global warming. And the third one is the N2O, still have a life more than 100 years. Ozone depletion is not a challenge, but it is around 300 times more potent global warming than the carbon dioxide. So that's why these three gases are main culprit for this global warming phenomena. As discussed earlier, these certain CFCs and CFCs which are used in refrigerants mainly are also a very serious concern in context of ozone depletion, not for global warming. Some are also contributing to global warming as well, but their real challenge uh, is the ozone depletion. That is why many of these has already been phased out to avoid the ozone depletion. These water vapors and the CFCs and HCFCs actually move upwards and reaches through this stratosphere layer as well. And when we see these like CFCs and HCFCs, they have a very long life, like 50 to 100 years. Um, Very high ozone depletion potential, and at the same time they have a very high global warming potential as well. That's why these are been very much regulated, and many of them has already phased out. Methane also escapes to the stratosphere from troposphere. Like we earlier said, 12 years life with a 28 to 36 times more potent global warming potential. N2 also reaches to the stratosphere, and at the same time, N2O is naturally also made through lightning of clouds. And actually, when the lightning of clouds occur, it is transformed into NO and NO2, which are less harmful for the environment. So when this N2O reaches above the lightning area and escaped to stratosphere, actually it kills the stratosphere ozone, which is a good ozone, and they protect us from harmful uh, rays from the sun, ultraviolet rays. So these CFCs, HCFCs, and N2O directly uh, depletes the ozone, and the main contributor for the ozone depletion when this phenomena was understood, and that is why CFCs and HCFCs has been very much phased out, and eventually the ozone is healing to a level where it is still protecting us, and the main holes have been very much healed by the natural processes. So like when we use the CO2 as a benchmark for global warming potential, for the same we use a CFC 11 basis for the ozone depletion potential. We take carbon dioxide as a 1, and similarly for the CFC 11 we take the ozone depletion potential to 1. And here we see the basically the pollutants which are mainly generated and remain in this troposphere where we all live and exposed to it in our day-to-day life. These creates the health hazards, physical hazards, and environmental hazards as well. It deteriorates the environmental conditions. It deteriorates the air quality around us. It also hinders the air visibility in some areas as well, and the N2O, CH4, and CO2 are main contributor to the not directly to the air quality, but these are important for the global warming uh, connection, and one of the main reason for the climatic changes, where we have increased concentration of carbon dioxide and other GHG emissions in to the atmosphere. So this was a kind of a brief landscape of air pollutants and their role in climate change, and what other serious consequence we can face due to these air pollutants. I tried to sum up these in a short span of time. So thanks a lot for watching and staying tuned for the channel. Uh, and please visit again. I'll be coming up with more interesting topics like this in future as well. Thank you for watching.